Hello everyone, welcome to Amazon Web Services Machine Learning Operations with AWS Masterclass, the seventh project of this course, and it is Music Rating Recommender using machine learning with CI/CD deployment in AWS. Okay, so let us see some glimpse about this, what we are going to do. So in this era of digital music streaming services, Music Rating Recommendation project utilize machine learning algorithms to enhance the music discovery experience for the users as well as the creators. And yeah, we are having a data set which contains a lot of musical information. So I got this data set from Amazon itself, and it will be shared in the downloadables. Please make use of it. It's actually a huge data set, and there are a lot of columns we are having, a lot of features, and we also have something known as a rating. So this data set contains information about the songs and also ratings of the songs from users. So we have to analyze this, and then we have to try to fit this in a way that it can be used for a rating recommendation for the creator as well as the listeners experience. And yeah, so let us go and use this hands-on. So the objective for this project is to first do the experimentation part, and then what we have to do is we have to convert it in a CI/CD mode with AWS. So let us go into the notebook first, and yeah, I have my notebook here. So let me just load the required libraries, and let me load the dataset music.csv music dataset. Yes, matplotlib is building, so yeah, it will be completed in a moment. Yeah, it has been completed. So yeah, let us go and check the shape of it. And what you can see is totally we are having around 2,64,000 rows, song details, and then 39 features about that song. Okay, and let me go and get the head of it. And this is what my data set is. So I'm having the music details, like every column is going to have a rating. And yeah, you can see the rating starts from 1 and then 4, 5, 3. So we have to analyze what all rating we have here, the length of the song, the energy, acousticness, balance, pitchness. So these are a lot of the musical details they are having, and that's what our data set is. So it's a huge data set because it's having 39 rows and 2,64,000 columns, and also you can see some unnamed columns there. It's maybe like we have generated it from the Amazon, so from the AWS, so some mistake has been happened there. So one index column has been added as an extra column. Okay, we have to handle this too. And let us go and get the column names. So if you want to see, these are all the column names we are having, starting from rating, then length, energy, etc. So it's a big data set with lot of features. And let me go and get the value count. So if you see in the rating, the value counts, if I see it, I'm having lot of like the rating starts from 1 to 5. So we have 5 types of rating: 1, 2, 3, and 4, and 5. And 4 like having the most rating, 77,000. And the rating 3 is like in 74,000. Rating 5 is 58,000. Rating 2 is 38,000. And rating 1 is 15,000. So yeah, from this is our target. Okay, it is like you can handle it as a multi-class classification. But once again, when you go for this classification kind of problem, so you have to worry about the balance of your data set. And what we can see is a clear imbalance here. So if I go and get the percentage of it, it seems like the 4 and 3, they are around 29 and 28%, 5 is around 21%, 1 and 2 are 5% and 14%. So this is obviously going to be an issue here because we have these the most, and this rating is very least only. So the model may become biased over this side. So whatever you give, they give good rating, and this can be neglected because it's totally they are covering around 20% only. So this is actually a issue. So if you want to handle this as a multi-class classification, okay, so when you go for like with this imbalanced data set, it is not going to be a good task. What you can do is, so if you want to consider it as a multi-class classification only and proceed with that, then you have to go for the sampling technique. And here you cannot go for oversampling because we have 5 classes, and enhancing our 4 classes is like going to manipulate a lot of manually created values. That not actually a good value, and that's not a good thing according to this context. And also, if you go for undersampling, then you may have lose a lot of data because here you are having a lot of data, right? We are having around 2,64,000, and this is like a good data, very huge. But we are going for undersampling, then it is going to be some issues with that too, because when you wonder like you have to go with this 5% in all the places, then it is going to affect your data also. So instead, what you can do is, if you just count the percentage of 1, 2, and 3. So this is a solution which, you have to understand the data set. Whatever required, you have to do it based on the problem you are going to solve. Okay. So what I have done is, I calculated the percentage of 1 and 2. So totally they comes around roughly 20%. And if you add 3 also with them, we are getting around 48%. Okay, so 1, 2, and 3 rating combines to form 48%, and the remaining 4 and 5, if you add it, it is around 51%. So this is actually a good thing. So what you can do is, you can create a column in the name new rating, where you can map the 4 and 5 as positive or hit, something like that, and 1, 2, 3 as negative or flop, or something like that if you mention it. Okay, so what we are doing is, we are creating a new column and mapping it. And what this is going to give us in the new rating, we have around the positive is around 51% and the negative is around 48%. So we store the originality of the data set, and we are solving the imbalance problem too. So this data set now is kind of balanced. This is actually a good thing. You can proceed with that. But now we are considering it as a binary classification problem. So based on the requirement, if you want to go for a multi-class classification, then you can proceed it. But you cannot directly go with that. You have to go for undersampling or oversampling. But here we have tried to manage or manipulate with the data we are having itself. Okay, and we are having around 51% and 48%. And let me go and get the head. Yeah, our new column is here in the new rating, the positive and negative. Okay, so let us get some describe the statistical summary of this, all the columns. So in this problem, we'll just focus our we'll shift our focus from the data analysis part towards the model enhancement part. So in this project, we'll try to do that. Okay, so let us check the basic exploratory data analysis and then move into the modeling part. So if I go and get isNull.sum, so let us check for null values in this data set. And remember, this data set is huge, so let us check. And this data set from AWS is actually good because we don't have any null values here. It seems like everything is fine. Okay, and let us get the data types. So this unnamed 0, we are going to neglect it. It's integer, and remaining everything is in float. And finally, we have created one new, right? So that is in object. So that's fine. So I'm going to get whichever is equal to float, which means all the columns, okay, features apart from this new rating. So let me go and get a plot of it. KDE plot 1 by 1. Since it's a huge, it is going to take some time to plot all the figures because we are plotting a lot of columns, right? So we'll wait for it to complete. Yeah, we got the graph now, and we can see like these are continuous values, like the rating. So yeah, we have some of the, so this is a categorical value, the rating, and some of the continuous values in their graphs. KDE plot, instrumentalness, liveness, speechiness. So we can see a wide range of things having here. So what I'm going to do is, so I'm going to take this, where I'm going to take everything, okay, wherever the object, okay, which is not equal to object. So new rating is object, so I'm just leaving that and taking everything which is from the second, because I don't want the rating to be included. I can start with the length, okay. So this will take from length till the end, which is not including the output, and these are all going to be my features, right? So in this features, let me go and use standard scalar and fit and transform them in one line. Let us transform everything using standard scalar, and let me go and use get. And this is what I'm having using standard scalar. So now we have scaled all those values all the features, and we have to encode this new rating, right? We cannot give this text directly, we have to encode it either 0 or 1. So let me go with the label encoder and fit and transform it to, and if I go and get dataset.head, so this is my dataset finally I'm having. And with that, what I'm going to do is, if I go and take from 2 till 38, the column starting from length till the end, all the features will be having, right? So I'm just going to get all the data from X. Okay, in X I'm going to store these things. In Y I'll store the new rating, which is my output. And once this is done, I can go and get train test split, right? So I can split them into X-train, X-test, Y-train and Y-test. And let us go with test size of 0.2 and random state of 12, or any random state. Please keep it constant so that same shuffling will happen. So now we have split it into parts. So let me go and use, first let us go with k nearest neighbor classifier, okay, from neighbors. So let us go and fit it and then predict it. It's a huge data set, it will take some time to run, maybe within a minute it will be completed. Then we can go and evaluate it. Yeah, the training has been completed, so let us go and calculate the accuracy score and then confusion matrix and classification report. And what we can see is our KNN, okay, so it has k nearest neighbor has given us 81.85%, nearly up to 82% we got it. We can go and get a confusion matrix. We can pass it to a heat map also. So it's a huge data set, right? So it has performed really well, and only 4,000 has been went here and there wrongly predicted. And let us go and get the classification report too. Okay, so how precise they are working. This is actually good. Okay, since our data set may have imbalance, but what we have done is we have converted into a binary classification, and we have saved the originality of the data set, right? And yeah, so let me go with what we are going to do is, we got around some percent, right? 81.85. So let us try to play with this. So let me try to get some f underscore classic score, okay, and then get we'll try to take some other columns, extract, and then try to get the output. So let me just reload the X-train, X-test and Y-train, Y-test, and go with feature selection. So select k best f underscore class of test with k value as 30. So let us try to go with best 30. Okay, so let me get the columns. These are the important columns, and yeah, now let me store in X-train and X-test. With that, let me just go and fit the model. Yeah, the fitting has been done. Let us go and check the accuracy score for it. Okay, so we are getting around 0.81%, and here we got around 8185. Yeah, here 8163. So it has been dipped a little bit. Okay, and this may go either side, it may increase or decrease. So that's up to the content or the data we are having. Let us go and use with XGBoost now. We'll try with XGBoost, and let us try to fit it with XGBoost classifier, and let it complete, and let us see the score for it. Yeah, the training has been done, so an answer has been predicted. So let us calculate the accuracy score. So XGBoost classifier is giving around 83%. And we haven't gone into this topic, which is called as the hyperparameter optimization. So let us try what it is. So if you go and see your algorithm, if you just click your cursor here and then press shift plus tab, you can see some window will open, and if you click plus here, it is going to show you what all the parameters it have, what is the number of estimators, what is the maximum depth, what is the maximum leaves. Okay, so these are a lot of parameters for this algorithm, which is, it will have the default values at first. Okay, so it will run with that value. So that may or may not be good for your data because it's a default value, but you can go and change these values. You can set some hyperparameters, but the thing is, you don't know which is a good parameter, right? So in that case, what you can do is, you can go and call from sklearn.model selection. You can import this randomized search CV. Okay, it's a randomized search cost validation. So what this guy is going to do is, you have to give some parameters. Okay, we'll be giving it in this format in a dictionary with list. So for learning rate, please try this combination. For max depth, please try this combination. So likewise, I can give some combinations here. So what it will do is it will try to fit in this multiple combination. Okay, it will use this randomized search CV. You have to pass which is the algorithm. So I'll go with XGBoost classifier, and the parameters is this parameters, and how many iterations, how much it should be done. We set this cross validation to 5 and let it run. And what we can do is it is going to take some huge time for this to complete, but when it completes it will give you which is the good combination, and then you can go, for example, you can go and get the best parameter, and whichever best parameter you are getting the values from here, that values if you fit it, then it is going to give you some good output. Previously we got around 83%, right? We'll try to evaluate with this, and these are some of set of the values. It's not like this values only. For this values which is the good output it will give. Sometimes if you miss some part of the values, your accuracy may go down too. So let us check with these set of values whether it is increasing or not. So first let me ready this, and then using this random underscore search I have to fit the X train and Y train. So let me first fit it. We'll wait for this to complete. So now this fitting has been completed. So let us go and get the best parameters from it. So what we can do is you can go and call this variable random underscore search and go and get the best underscore params. So this is going to give you which is the best parameters from this combination, which is the best, is giving good output. Okay, so the minimum child weight, let it be 5, maximum depth it is suggesting is 10, the learning rate is 0.1, okay, the gamma value is 0.4, and the column sample by tree, let us keep it to 0.7. So with this what we are going to do is we are going to fit. Okay, so we are going to add this to the XGB classifier, and this tuned one I am going to fit it and then ask the model to predict it. So let us run this and verify how much the answer it is giving. So this, from this combination it is trying to give you the best combination. So we have to wait and see whether it is overcoming this 83%, which is the base one. Whether that is good or this is good, we have to decide from this one. Okay, so once this is completed you can go and continue with the next steps. Okay, we'll see about this result, and we can go and continue by creating a CI/CD pipeline in AWS. Yeah, now the fitting has been done and the model has predicted. So let us go and get the score of it. Yeah, so you can see the difference now. We went with the same classifier XGBoost, but previously we got around 83%, now we are getting around 85%. So how this is, we are adjusted this, right? So with further more combinations you can go and get some more improved accuracy with this method too. And you can also go for reducing the features, going for feature selection or feature extraction, and try to improve your output. Let us go and get some reports from this. Yeah, so from 4000 we have reduced it to around 3700. The mistakes still a 15% is went into wrong situations. Yeah, so with that we'll just note it down first what all the pre-processing we are going to do. So the thing is we have done, yeah, so first we have mapped our outputs, right? We have created a new output, and then we went into scaling them and then encoding the output and then splitting them into X and Y. So that's what the basic pre-processing we have done here. So this we have to execute in our project also. So let me go and show you the pipelines. Okay, I have created this in the model build. If you go and see the pipeline, in that the music folder preprocess.py, so this should contain all the changes. For example, yeah, first the data is read and then it is mapped. Okay, the new rating has been created and then label encoder to new for the new rating, and then pre-processing to pre-process everything, and then taking X and Y, or taking from the second column till the end, and the feature the output. Okay, so this will store the X and Y values simply. So the next step is going into the pipeline mode. So first let us go and get some output to the XGBoost itself. So if it is good, we can continue with that, or else we can go and use other options. So these are going to be the common things, but once again, if you are altering this, what you have to verify is, since this is a binary classification problem, let us go with the same XGBoost, but the hyperparameters, you can go and alter this too. So let me go with binary logistic. Okay, and then this will fit, and the model will be predicted. Evaluation will be done here. And in the step, okay, let us change this. Let me give some high barrier around 0.8 for me to verify this. Okay, and condition greater than, please make sure you are doing that. Okay, first try we'll go with 0.7 itself. Okay, and other than that, this is going to be same, and you can alter the name for the condition steps. And in the evaluate file, this is the binary classification, so you are going with accuracy score. Okay, and then rounding it off and then getting the output. Okay, so let us store it in the JS1 file, which will be taken from the pipeline itself. So now after doing all these changes, I have to go and push it, right? So we have to, this is staged, so let me just commit it first. Yeah, and yeah, we can go and push it, and we should see the pipeline got triggered in the code pipeline. So if I go and check the pipelines, this is in progress. Okay, and the build is started, so let's go and check. And to the pipelines will start as soon as possible. So in the pipelines, if you go and check, this is a pipeline 57 minutes ago. First I have stopped that basic steps. So now I have done the changes and pushed it, right? So let it run, and it will start only when here the waiting for the execution to be completed. That screen is printing, and this will do the unit test, which means whatever change you are doing, if you have any kind of error with that code, anything library missing or any syntax errors, this is going to be stopped here itself. If everything is fine, then only it will go into your pipeline. So now the pipeline has been started. Okay, the music data, so let's changes I can observe it is running my code only. So let us go and wait for this to complete. So this will take around 10 to 12 minutes to wind up. So we'll wait for this to complete. Yeah, the pipeline has been completed. So it starts from pre-processing, then training, then evaluation, and then finally going into model registry. So now we have to go and approve it in the model registry. So let us go and approve this. Yeah, the version 1 it's pending. So let us go and check the score of it first. So this one is performing like 1, which means 100%. So previously we have seen some 0.75, 0.8. Surprisingly, this XGBoost is performing really very good. With this kind of data we got from AWS, so this is actually very good. So what I can do is I can go and manually update the status and approve it. So once this is done, it is going to trigger the pipeline in code deploy. So this is now will wind up. So in the pipeline, so now the code pipeline will get started, and 2 endpoints will be created, which can be used for or further invoke and then testing. So one is from staging, another one is from production. So let it run. So this will go and create endpoint. So you can, it is better to go and watch it manually and then trying to verifying whether it is working properly or not. If your code is fine, then it will run. If you have any kind of simple issues, then it will be error in the first stage itself. So you cannot proceed to this level. So once it is running to this step, then it means it is working really fine. So let me go with SageMaker, and yeah, I will try to see the endpoints in the inference models and the endpoints. Yeah, the staging endpoint has been creating. So once this has been created, it has been used for testing, and where the tests, once if it is responding properly and if you are getting some good output from it, then it can be deployed to the production. Okay, so let us wait for this to complete, and we have to approve it manually in the later part. Now both the stages have been completed and the testing is done. It's successful. So I have to go and review it and let us approve it. So this should trigger another endpoint creation. So once this is started, once the transition is complete, this is going on. Once this is wind up, it will go into the production where another endpoint will be created, and you can use it for further testing and giving it to your clients and working on it. So that's what a CI/CD pipeline is. So the main objective of this project is to create a system where it can be used for, if you provide the details of the music, it should give you whether it is going to be a hit or flop, whether the rating can be more than 5, like it's 5 4 or in the range of 1 2 3. So that's how we have defined it. And yeah, we are successful in that. So with this endpoint you can use it to invoke it like we did in the previous class too. And the production endpoint is now in the it is in creation. So these endpoints are the important things. So this is where your model is stored. This is where you are going to use it for your testing of your output, etc. And previously, if we have another endpoint, we can try with that too. The staging endpoint, which is in service, and the alarms is 0. If anything goes in sideways, it will going to give you alarm, and whatever the issues has been done. Yeah. So the disk utilization and the performance, and you can create an alarm too, like if something the threshold value goes below or above greater than this value, if anything not goes good, then you can create an alarm which is going to give you some intimidation that this is not going in a good manner. Okay, since it is now only it's created, right, so there won't be much data for you. Only when it is keep on running for a long time you can get some information from it. Yeah, this has been creating, and here too we can see in our endpoint. The production endpoint is, I think it has been deployed. Yeah, it's creating. Okay, so staging is like for your testing. You can do all the tests here and everything. If it is okay, you can go with the next step, and you can add once again the data quality or model quality monitoring to see the drift often like every day or every hour to check whether it is working fine or not. Yeah, let it create, and once it is created, this pipeline production is going to be completed, and that will end our success of this project. Yeah, just this template is really useful for you if you don't have idea about the proper DevOps tools building. So we can use this where we are just focusing on here. And once again, if you are renaming this folder name, then what you have to do is in the build file, in the build spec or YAML file, you have to change the name of it of the module. Then only that module will be taken. Otherwise, it will search for Abaddon and you have to change it to music. It is going to give you an error. So please be careful with that too. And yeah, this is in service, which means it will wind up soon. So now we have our endpoint which is in production, which is used for the clients, and you can work if you are working in a project, real-time project, will be used. Okay, and yeah, the experiments, etc. You can test. Okay, you can add some tests here which can be done automatically. Everything can be done here. Yeah, this has been completed, and this will help us to wind up this project. 2 of it is succeeded and the endpoint is running. And if you are practicing like me, then what you can do is if it is okay for you to wind up everything, it is better to go and delete the endpoints after doing all the process. Okay, and this will help you to stop the incurring costs. And once again, this is going to cost you, once you use CodeBuild, they are going to charge you nearly $1, like roughly every day. Like I used to get these updates, so please be careful with that too. Okay, so once you are complete, you can wind up these things.